In part A of the question, we're asked to find the magnitude of the acceleration of the object as it slides down the plane. I've already started to draw the diagram of what's actually happening. What we do know is it's sliding down the plane. We're asked to find the acceleration, so obviously the acceleration is acting down the plane. We have a frictional force trying to hold the object on the plane and stop it moving. And we also have components of the weight both perpendicular to the plane, which is 6.5 g cos alpha, and parallel to the plane of 6.5 g sine alpha. We also have reaction to take into account, which will help us calculate that frictional force. We're also given that sine alpha is 5/13. This is just to extend the question slightly. If we were to draw a right angled triangle with 5 being the opposite, 13 being the hypotenuse, we can see it's a Pythagorean triple with the adjacent being 12. That would make cos alpha equal to 12/13, which we might need later when we come to calculate the frictional force. So in the first instance, the only thing we really don't know is the frictional force. Frictional force is equal to coefficient of friction times the reaction. In this case, coefficient of friction is a fifth, or 0.2, and the reaction we can see is equal to 6.5 g cos alpha. That's the weight acting perpendicular to the slope of the object. Cos alpha we know is 12/13. So now we have a way of calculating the frictional force. That comes out to be 11.76 newtons, which we can now apply to our diagram. The next thing to do would be to apply Newton's second law down the slope in the direction of acceleration, and we can see that we have the component of the weight of the object pulling it down the slope minus the frictional force trying to hold it steady is equal to the mass of the object, 6.5, times its acceleration. The only thing missing here is the sine alpha, which we were given in the start of the question. So that's 6.5 g times 5/13 minus 11.76 is equal to 6.5 times the acceleration. Dividing through by 6.5, we can then calculate the acceleration. And in this case, acceleration is equal to 1.96 meters per second squared.